again. I want to do two things with you guys. Hello, man. Thank you. I want to finish this up, and then I want to look at one other problem. On Nasiba, if you'd been on your A game, you could have gotten yourself a free pass. I always like double check that, especially when it goes to certain students. I'm like, nope, you don't need a freebie. Okay, so yesterday we figured out the area of an 80-inch TV. Can you guys remind me how they talk about the dimensions of a TV? Because they only give us one number. How do they talk about a television? When they say an 80-inch TV or a 55-inch TV, what are they measuring? The diameter? Diagonal, sorry, I misheard. Diagonal. So upper corner to lower corner. The farthest away, still measuring just one dimensionally. And yesterday we used that information to calculate the area. What is the aspect ratio of a television? 16 to 9. What does that mean?
Like the height and the width.
The height, so all TVs are 16 inches by 9 inches? What does that mean?
That's like the base.
Sort of. It's the proportions, the ratio of the length and the height. So if the bottom gets bigger, the side gets bigger using this same fraction. If the bottom gets doubled, the height gets doubled. If the bottom gets tripled, the height gets tripled. If it gets multiplied by 4.5, the height gets multiplied by 4.5. Like whatever you do to one side, you have to do the other. If I draw this diagonal in here, what kind of a shape do we end up making? A right triangle, yes. If you have not already drawn that in, please go ahead and do that. What should I label that on this? 55 inches. You guys okay if I use the abbreviation? Did I share with you guys yesterday how I remembered the difference between which one is inches and which one is feet?
Mm-hmm.
Yeah.
It's the syllables.
Mm-hmm.
Took me forever to figure that out. But now I always remember it. So how do I use that aspect ratio to help me from here?
Don't you have to
Sort of. I've got 16 on one side and 9 for the height. And it's just 16, like 16 inches, 9 inches?
centimeters?
16, what'd you say? X. And 9 X.
I said
That's okay. Whatever the X is the same in both spots.
Right.
If we were multiplying by something different, I would need to use a different variable. So that's what's going to keep this proportion the same. You said we made a right triangle here, correct? What can I use with right triangles?
1/2 based on 10.
I can for the area.
Oh, crap. Don't you have to do something divided by 2?
Okay. I apologize for that, guys. What can I use again with right triangles that only works with right triangles?
P equals A plus B. Am I saying that right so far? I just
A squared plus B squared
Oh.
equals C squared. We can use Pythagorean theorem.
Yeah.
There's only one piece of that equation where it has to be a specific part of the right triangle. Which piece? C. C has to be which part? The longest side. So on our triangle, which part would that be? The 55. So we're going to put 55 in the place of that C. Does it matter which leg I put in for A and which one goes in for B? Nope.
No.
So we've got 16x for one of them and 9x for the other one. Again, doesn't matter, interchangeable. What does it mean to square something, though? Times, not double. Double means times by 2. Times it by itself. When I make those corrections, it's not because I'm trying to like put anybody down. It's just really important the way we think about it, because that ends up being the way we'll take it and try to use it on our calculators. And I want to make sure that we all have like a correct understanding that will lead to a correct process. Okay, so I'm going to do 16x times another 16x right here, right? So how do I do that? 256, because I've got 16 times 16. And then I'm still doing also x times x. What is x times x? X squared. Just like 5 times 5 is 5 squared. X times x is x squared. Inches times inches is inches squared. Anytime I take something and I multiply it by itself, I can say that it's that thing squared. So talk to me about the 9x that I'm taking and squaring. 81x squared. Thank you. And then over here, what do I do? You said 3,000 what? 25 from doing 55 times 55. 3,025. So far, so good? Literally following the exact same process that we did yesterday. What else can I do? I can add the like terms. These are like terms because it's same variable, same power. When I add things together, it won't change my variable and it won't change my power. All I do is take those front numbers and add them together. So what do I get when I do that? 337x squared equals 3,025. What do I do from there? Divide by 337. What is 3,025 divided by 337? 8.976. That's almost what? Are you guys okay if we just round it to 9? Yeah. I mean, the whole question that we're after here is, does it have more than double the area? So if I round up just a little bit, I'm actually giving them the benefit of the doubt there. All right, so I'm going to call this x squared is about, so I've got some squigglies, 9. Why do you guys think I wanted to round that up to 9? There we go. I'm going to square root both sides, and I know the square root of 9. 3. So x is about 3. What does that mean as I'm thinking about the length and the width of this 55-inch TV?
It'll be what you can put x in 16.
Yeah, so that means the base is 16 3 times, and the height is 9 3 times. So I'm going to do 16 times 3 and 9 times 3. What is 16 times 3? 48. What units should I put with that? Inches. 48 inches, that's 4 feet. It's about this big across. Pretty decent size,
We
right?
just did all that just to get 4 feet.
Yeah. But we're not done with the problem. That's not where we're stopping.
This is the tough problem.
What is the width of the TV? 27 inches. A little bit more than 2 feet. So how do I take that then and find the area of this television? We do. I'm going to do 48 inches times 27 inches And what do we get? 1,200, you said, and 96? What would our units be on that?
Inches squared.
Inches squared. Why inches squared?
Because it's
Inches times inches. Just like 5 times 5 is 5 squared. X times x is x squared. Inches times inches is inches squared. If I'm comparing that to something else, wouldn't it be easier if that was kind of a prettier number? 1296 isn't horrible, but it's about how big if I round it up? Round up to the nearest 100.
12,000. I mean 1,200 and stuff.
1296 is about 1200.
Oh, 13.
It's about 1300. Right about 1,300 square inches. Ballpark, right? I'm only rounding it there because I want to take it and compare it. If you guys flip over, can you tell me, we said yesterday the 80-inch TV had an area of what? About. 2733.
15 inches squared.
Perfect. So I'm just going to leave it as 2733 inches squared because, again, I'm just kind of rounding. And a 55-inch TV is what again?
1,296.
Yep. Right about 1,300 inches squared. What was the claim?
That the 80-inch TV was more than 2 times bigger than the 55-inch TV.
Yeah. That the 80-inch TV has more than twice the area of the 55-inch TV. So let's evaluate this claim. 80-inch TV was that 2733. More than, that would be an inequality, right? More than, bigger than, greater than. Alligator eats the bigger thing, right? So it should be like this. We're trying to determine if this is true. Twice as much means to do what to the area of the other TV? Multiplied by 2. So I would do 2 times 1,300 inches squared. What is 2 times 1,300? 2,600. So I'm going to recopy this here. And I'm going to simplify the other side of it. 2,600 inches squared. Is that true? Is 2,700 something bigger than 2,600 something? So is the claim true or false? True. This claim is true.
So do you always want to do that? Do you
Always want to do what?
For the area, like you did for 9 as well. Like if you're like that close, it doesn't really matter.
It depends on what the question is.
Okay.
In this case, our question was comparing two things, and I wanted to know if one was more than twice as big, so I took that smaller thing, and it's okay for me to kind of round that guy up, little bits, because if I round him up and then I times it by 2, the other one should still be bigger, right? Yeah, yes ma'am.
To solve the last part of it, could you do 2,732 divided by 1,000?
We could, yeah. Here, in fact, let's go a little bit down below. How much more area does the 80-inch TV have than the 55-inch TV? This is kind of another way of thinking through it, too. We said 2733 inches squared. That's our 80-inch TV. Minus 1,300 inches squared. That would be the 55-inch TV. And I'll do what you suggested here in just a minute, because there's lots of different ways that we could go about showing that it's more than twice as much. If I subtract these two things, what do I get?
1,472.
And that's more than another 55-inch TV, isn't it? So you could hang two 55-inch TVs on your wall and take up the same amount of space as one 80-inch TV. Actually, you take up a little bit less space than the 80-inch TV. I'm going to do what you suggested and divide them. 2733 inches squared divided by 1,300 inches squared. Here's our 80-inch TV, our 55-inch TV. What would cancel out between the top and the bottom? Inches squared is going to cancel out. And so then I just divide those two numbers. And I know it doesn't come out pretty, but it comes out to about what? 2.1 times bigger. That would be another way of saying that it's more than twice as big. We got a number that was bigger than 2. Absolutely. Great ways to think through this. Is the advertisement accurate? Yes, we already said that advertisement was accurate. Yes, the 80-inch TV has more than double the area of a 55-inch TV. With that, I want to look at one other problem with you guys. It's back a couple pages. I find this particular problem really interesting. We are going to go back to page 139. Page 139, so backwards about 5 pages. $139, yep. I don't even think the book goes up to $189.
That's what I was
Okay. You guys don't have nearly as much space as I have up on my screen because I just clipped this one question and put it up here. I just find this one really interesting because everybody at some point goes to the doctor. Everybody at some point gets given medication, or even if you don't go to the doctor, you've probably taken some stuff over the counter. When you pick up like cough syrup or Tylenol or ibuprofen, you know how there's that side with like all that information on it? And it'll tell you like the dosing, it'll tell you how many pills you should take, what's the recommended amount. It tells you the strength of each of these, and it usually has a big old warning on it. It'll say things like you can take up to 2 pills every 4 hours, but then it says things like do not exceed 6 pills in 24 hours. Why do you think they put that on there?
I don't be listening.
You don't listen to them? Huh? You don't overdose, absolutely. What would be the problem with taking too much? Overdosing, but what would that do?
Feel sick.
Could kill you, could make you feel sick. It could do lots of different things. Is the children's strength the same, like milligrams or milliliters as the adult strength? Why not?
Their immune system is weaker.
Their immune system is weaker. Anything else that is profoundly different about a child versus an adult?
Their bones aren't fully there.
Their bones aren't fully there. They're still pretty much made of cartilage. What's the most obvious difference between an infant and an adult? They're smaller. Like, all things considered, their bodies are much, much smaller. If I have a very small cup and I have a very large cup and I want to fill them with the same amount of liquid, if I fill up the large cup and then I dump it into the little one, what will happen?
It'll overflow.
It'll overflow. So what would be okay for someone in a larger body, you can't have the same amount in the little body. An overdose amount in a small body would be possibly just a normal adult portion. You have to have a certain amount of medication in your system or it won't do anything at all. Too much and it's dangerous, too little and it's not effective. So finding that correct range for the dosage is really important. Do you guys know why the doctor himself doesn't give you medication unless it's a sample? I'm not talking about samples. I'm talking about write you a prescription, and then you can't just turn around and hand it back to him and he gives you the meds. Why not? Where do you have to go for that? Pharmacy. Can any old person be a pharmacist?
Yes. No, if you're crazy, you can't.
Like, you can't just walk in and apply to be a pharmacist, right?
Right. You have to go to school for that.
You have to go to school for it. Does anybody know how long you have to go to school for that?
6 years.
6 years. It's more than just a regular 4-year college degree. Why do you think it takes so long?
Because it's medicine.
It's medicine.
Body.
They're not the prescribing ones. They are the check in a checks and balances. Everybody makes mistakes. Doctors study medicine. They need to know about all these different medications. They need to know about proper dosage ranges, but they're also humans. Humans make mistakes. The pharmacist is there to help catch some of those mistakes, to also make sure that there's no interactions between different medications, that this doctor that you have and this doctor that you have might not know about each other's medicines. The pharmacist can go like, whoa, these two don't play nicely together. We need to find something else. So that pharmacist kind of stands in the middle and watches for potential problems. So I want you to put that kind of a mind frame on as we're reading through this problem. And we're going to see if we can figure out, first of all, what in the world it's saying, and then how to determine the answer to this. So we have a doctor, and they have ordered 250 milligrams of a medication called Rocephin. I have no idea what Rocephin is for. I want to look it up at some point, though. It's to be taken by what? What kind of a person is taking this medication? An infant. How big's that infant? 19.8 pounds. Well, it might be like a 1-year-old.
It treats infections.
Treats infections, so probably like an antibiotic kind of thing. Why do you think it's important that they gave us the weight of that baby? Absolutely. If this was a baby in like the NICU, a premature baby, very different dosage probably than 19.8 pounds, which is about the size of a 1-year-old. How often are they supposed to take this medicine? Every 8 hours. Is that a whole day?
What is Rocephin?
It's an antibiotic, apparently. It treats infections. How many times in a day is the baby going to take this medicine? 3. How did you get that? Yeah, we do 8 hours times 3, and we get what? What'd you say? 24 hours. So each time the baby takes the medicine, they get 250 milligrams, right? So over the course of a whole day, I'm thinking about those like Tylenol packages. They're like, don't go over this much in a whole day. How much in a whole day is going into the baby's body?
70 milligrams.
How much?
70.
Close. Very, very close. It's 250 every time they take it. 750. If that's what you said, I apologize. I just couldn't hear it very well. Gotta love the masks. Tell me how you figured that out.
You just add them, all of them, like 250,
250, 250, 250. Or instead of adding it repeatedly, we could multiply. Same exact thing. Repeated addition is what multiplication is. So 250 milligrams of medication times 3 times a day. And we get a grand total of 750 milligrams each day. Technically, we've done a little bit of converting here. None of it has been horrible amounts of converting. We've gone from per dose to per day, right? So we had to figure out how many doses in a day. The medication label that the pharmacist looks at to make sure that this actually is within that effective range has to be enough that it does something, but not so much that they overdose on it. We've got this little window. What is that window? 75 to 150 what? Milligrams per kilogram per day. We've already got the per day part figured out because we figured out how much they're taking each day. When they talk about milligrams, what do you think that's in reference to? Milligrams of what? Of the drug. Milligrams of the medicine. Because you take this in very small amounts, right? So 75 to 150 milligrams of medicine, and then it says per kilogram. What in the world is that kilograms talking about?
What do you mean?
Good question. I'm just kind of asking what, it's got these 2 units. I know the milligrams is talking about the medicine. What is would somebody take a whole kilogram of this medicine? That's a lot. So what must the kilograms be talking about if it's not talking about the medicine?
Per dosage?
Close.
Maybe it's a person's body.
Person's body. That kilogram is body weight. So for each kilogram that a person weighs, they want to keep it inside this range. So a bigger person can have more in their body, right? More milligrams overall. Kilograms is the body weight. Well, this baby is getting 750 milligrams each day. How much does the baby weigh? How much does the baby weigh? 19.8 pounds. But when you're talking about pharmaceuticals, to keep it consistent across not just the United States, but other countries as well, they talk about it in metric units, not the least of which is kilograms is mass, pounds is technically weight. You got 2 different things going on here. So how are we going to determine if this is the proper dosage for a baby? Convert the pounds into kilograms. So what is that conversion? 1 pound, 0.454 kilograms. And this is an approximation, but it's close enough. So we want to talk about the baby's weight in kilograms. The baby is 19.8 pounds. That's what that LBS is. I can take this 1 pound is equal to 4.54 kilograms, and I can set it up as a proportion either way, right? What do I want to cancel? The pounds. So that I end up with just what? Kilograms. So how should this proportion look?
1 pound at the bottom.
1 pound at the bottom.
0.45 at the top.
0.454, any units with that? Kilograms at the top. So now my pounds are going to cancel. So I want you guys to multiply those for me real quick so that we know what the baby's weight is in kilograms. You said 8 point what? 9892. Sorry, I just didn't hear the rest of it. 8.9892 kilograms. So here's the baby's weight, technically the baby's mass. So how do I determine if what the doctor prescribed fits in the right window?
Can you divide the 250 by the baby's weight?
Yes, we're going to divide, what am I going to divide though?
250 by the kilograms versus the baby's weight.
250? This window uses what measurement of time?
Oh.
3 times per day, so that
Yeah,
would be 7.
we want it a whole day, so we're going to use that 750. So we're going to do 750 milligrams of medicine each day. We're going to divide that by the baby's weight. Measured in kilograms now, because it wouldn't make any sense to divide it by pounds. That wouldn't give me the right way to compare it. 8.9892 kilogram baby. And we come up with what?
83.433.
You said 83.433 milligrams per kilogram. That'd be over 1 kilogram each day, or per day. Does that fall within the effective and safe window? Yes. Within the desired range. Too small, not effective. Too much, overdosing. And then definitely ineffective. Right there in that sweet spot. Awesome. Thank you guys for hanging with me through that. I wish they gave more room on the page. I find this one to be a really interesting problem because I often wonder, how do they know how much to prescribe? When they're like, I want you to take this and you need to, or especially if it's a long-term medication and the doctor's like, okay, I want you to go up about 25 milligrams. You're like, how did you decide that? I know part of it when it's in pill form and not liquid, they're like, well, it only comes in these denominations. How did the drug manufacturer decide that that was effective denominations to break it into? Like, what's all that goes into that? Find it wickedly interesting, and we can evaluate at least small little snippets of it just using what we know about conversions.